What I have here is a lab setup in order to help us check whether Newton's second law is true. So you've probably noticed that Newton's second law, acceleration equals the net force divided by the mass. It's with something we've been using in class where we haven't really shown it in lab yet. That's different than how we've done other things. This is a law of nature, of course it's verifiable, but it's a really tricky one to actually show. It's given my students, it's given me, it's given my colleagues a lot of trouble over the years. And now that we have a pretty good understanding of forces, I want to show one way that you could check to see if this is true. So I want to give a lot of credit to colleagues and students over the years who have come up with better and better ways to do this. So what I've got here is a set of weights sitting on a cart, which of course has its own weight. There's a string which passes over a pulley, and there's a weight hanging down freely. And what we're going to do is we're going to pull back the cart, and as it's being pulled by the hanging weight towards the edge of the table, that will be giving us the acceleration that we need to measure. Now, it's a little bit of a tricky lab to do for a couple reasons. One, you have to have a very good way of measuring acceleration. You got to be really precise on this. Fortunately, we have that. This pulley is what's called a smart pulley. And I'm sure you can see that there's a purple light on one of the plastic horns here. And this is called a photo gate. Right now, that purple light is visible on the other edge by a sensor. But when I pull the cart back, it gets blocked and unblocked as these holes move in and out of the way. So how quickly that happens, that actually lets the computer know how fast the cart is going. Interestingly enough, you can see that purple light, but I can't. It's not really purple. It's a color called infrared that our eyes can't see, but our cell phone cameras are sensitive to it. And for some reason, they display it as purple. So let's talk about what measurements we're actually going to be taking. If A equals F over m, we've got a little bit of a problem. We want to see what the effect of force is on acceleration, but also mass. And that's too many variables. You guys know that you can only change one independent variable at a time and see what effect it has on one dependent variable. So we got to break it down. So we're going to do one experiment where we check what effect changing the force has on acceleration, how pulling it harder would affect acceleration, and one experiment to check how changing the mass has an effect on acceleration. We basically have to control the other variable in each case, and that's why this is such a tricky experiment. So here's how it's going to work. Let's take a look at the free body diagram for this system. You can see I have the cart, which I've labeled mass 1, I have the hanging weight, which I've labeled mass 2, and these are the forces that are acting. The axis I'm interested in I have labeled X in orange, and it's horizontal on the table, and then the pulley turns it 90 degrees to vertical downward. The X forces just sum to the hanging weight. The two tension forces cancel. But since F equals ma, the m in this case is not the hanging weight or the cart, it's both. It's the whole system, m1 plus m2. So if we're only going to change the force without changing the mass, we have to make sure that m1 plus m2 stays constant. So the way colleagues and students have come up over the years to do this best is to have a number of weights initially riding on the cart, have your hanging weight, and then basically to swap out who's the hanging weight and who's on the cart. So we'll do the experiment multiple times, and that means the mass will stay the same because everybody's along for the ride, but only the hanging weight contributes to the force. So that's a way we can vary force. So basically, the way we're going to do it, we'll run the experiment and see what effect a 200 gram hanging weight has. Then we'll swap it out. We'll put a different weight on it. The other weight's back riding on the cart now. And we'll repeat the process. So I'm going to get the data for several different runs, varying the force but not varying the mass. And you'll see this after this movie on the Flickr album. So before you watch the next segment of this movie, go take a look at the screenshot on the Flickr album.